Okay, folks, welcome to one of your first lab experiments in CTC 115, which is quality control. And this is going to be one of the first labs that you will probably tackle and complete. And it's very easy. It's very simple. Just bear with me. There's a little bit of math, but guess what? Quality control is math in a way. So we've got to get really comfortable using these types of concepts that we're talking about in lecture. So we love this very first lab experiment for a number of different reasons. Number one, it does introduce you to a little bit of stats. Oh no, stats! So yeah, that's kind of the thing. So we're going to have to talk about, in this particular experiment, averages and standard deviations. Now, there's more to stats than average and standard deviation, but this is really one step in that direction, and we're going to take it a little slow, and we're going to go in baby steps, so that way it gets you a little bit more comfortable with stats and using Excel to do some calculations for you. And that's really all that this lab experiment is going to be about. Next up, not only does it do stats, which is a little bit of math, we're also going to learn how to use the analytical balance. For some of you, this might be your first course in CTC because this is an entry point. We normally offer this course in the spring, and people are more than welcome to sign up for this in the spring with no other previous CTC classes completed. And if so, great, good for you. We are glad that you are here, but at the same time, we do not want this to be so overwhelming that you're going to drop within the first week. So what we like about this lab as well is that it's a, hey, get to know the analytical balance moment. So it gives us a chance to touch base with the balances, show you how to take mass measurements, maybe how to print off receipt tickets, because those are a thing that we do sometimes. And it really just kind of puts a moment in perspective where if you are a new face to our program, we welcome you aboard. And then at the same time, we're also kind of showing you something a little basic that is a staple in our laboratory space. So that way you're not just kind of a fish out of water with this experiment or with some of the stuff that we do later on in the program. So there's two stats that we're going to focus on. The very first one is called average, and the next one is standard deviation. But we're going to make math teachers very unhappy, and we're going to get Excel to do these calculations for us. The only thing that I need to do in the laboratory space is make the recordings and the measurements and log those numbers down. That is it. That's all that I do. And then I'll let Excel do all of the other work for the stats portion of the experiment. All right. So in lecture, we've talked about average. We talked about standard deviation. Average, of course, is just the sum of the numbers divided by how many I actually have. So if I'm going to calculate the average grade on a particular lab experiment or a test or a quiz, then I'm going to take everyone that completed it and I'm going to add them all up, right? You get a 70, you get a 60, you get a 90, you get a 100. Darn it, I couldn't fail you. You get a 0. Ha ha! I win. All right, so I'm going to take all of those and I'm going to add them all up, and then I'm going to divide by the number of people that attempted it, right? So the same thing's going to happen here, but this time it's going to actually happen with pennies, because we're not going to let you assign grades. We're just going to let you measure some masses of pennies. Now, I know penny, R-I-P, oh no, so the current year is 2025, and pennies are no longer made, Doge. So, if it's not a penny, it could be a nickel, it could be a dime, it could be a quarter. I mean, it could be anything that we provide you, but it's going to be some type of object. And as of right now, we're still using pennies. We still have them. We're not going to destroy them. We're not going to throw them away. We have them in our lab space, and we can take the measurements of them. All right. This article, though, could change a little bit later in the future, of course, in the years, fast forwarding to 2030 or 2035. I might be here. I might not be here. I don't know. But this object can change depending on the particular year. As far as standard deviation goes, well, standard deviation, we said, hey, here's a dartboard and there's the bullseye. So we're going to throw darts at the bullseye. So I'm going to throw and throw and throw and throw. And I hope that my darts all get clustered in the same area. That is precision. And that is also kind of the idea of standard deviation. So it is how close are your measurements together. So we don't want you to be sloppy with this particular lab. We want you to take your time. We want you to take the mass of these pennies one by one by one by one, and we hope that all of these measurements are going to be really close. So standard deviation is one step in that direction. It is not the full story, but we take them again in baby steps. So you could calculate standard deviation on your own. Here it is. Oh God, who wants to do that? Nobody. So if I was in a math class, if I was in a statistics class, I would see this kind of stuff. And I would go, oh, okay, take your individual data point minus the average of all of the data points, and we're going to square it, and then we're going to add up all of those differences with every single data point, and then we're going to divide by the number of individual measurements that we took, minus 1 for the degrees of freedom. So this kind of idea here with standard deviation, we're just going to be like, not today, Satan. And the reason is because Excel can do this for us quite easily. So that's really all that we're focused on right now. I don't want you to get weirded out. Just bear with us. Have patience with us. We promise you this is not going to be as bad as what it kind of looks like. So for part one says personal data and your measurements. It says obtain a data sheet. Okay. And then we're going to look at pennies 1983 and higher. And the reason is because the percent composition changed after 1983. Up until 1983, pennies were made a certain way, and then in 1983, we get kind of a complete reformulation of something that begins to happen. And it is the different types of ratios of the metals that they choose to make the pennies with. So we want to make sure that it's 1983 or newer, not some of the older pennies that are still out there. And we will try our best to make sure that these are 1983 or newer as far as what we provide you. So it says use an analytical balance, find the masses of 30. Yeah, come on, folks. It's not going to take a lot of time to record 30 data points here. So with that said, I mean, you're still looking at like 10 minutes, give or take a little bit. That's all the time that it's going to take to record 30 pennies as far as their masses go. It says weigh them individually, of course, and you want to record those on the data sheet, and you want to make sure that you also record the year of that particular penny. So I've got a 2001 penny, so I'm going to record that, and then the mass of that penny is 2 point blah 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 grams. So I want to make sure that I write down that mass as well. So the balancer is going to provide you the mass. No calculations needed at this moment. It's just record 30 pennies and then have that data sheet ready to go. So that way you can use Excel to do the next portion of the lab experiment. All right. Number 3, it says using the data sheet, transfer the information to an Excel spreadsheet, and then mimic the layout of the data sheet as much as possible, including the years that you have analyzed. Using Excel, calculate the average and calculate the standard deviation. And then it says upload the Excel spreadsheet into the Canvas system, because I think we've did away with Blackboard at the moment, or print it off and turn it in. It's going to be one or the other. Your instructor will let you know what to do, and that could be me or it could be someone else, but we'll give you instructions on how to submit this laboratory data. All right, so within Canvas, here is the, something similar to the 115 when you log in, of course. And then there's going to be a laboratory section down here, and it says laboratory number 2, stats of a penny. And if I click the laboratory procedure link, and I'm not going to do that, but if you click that link, it's going to direct you to a page. And that page is going to provide you with the instructions that we have printed out for you already. We've stapled them. We've given them out. You've got a hard copy of this in the classroom setting. So don't feel the need to print them off. But if you do want to click it and review it before you come into lab, please do so, right? So that's why we make those available before you come in. Next up, under that same page, when you click this lab procedure, stats with a penny, you're also going to see another link and that link will say a spreadsheet. Okay, it will be a personal spreadsheet that you will record. All right, so when you click that and you download it, this is what you're going to kind of see. Something very similar to this. And I want to work you through the spreadsheet here so you know what to do as far as how to complete it and how to submit it. Now, the directions are going to say 30 pennies. We might feel sorry for you, and we might say, well, you know, this year we'll do 20, not 30. Or we'll be like, gosh, I feel really sorry for these people. So this year we're going to do 10 and not 30. Oh, please let us be the 10 penny class, because that means these things are going to happen even faster. So we will let you know exactly how many pennies to mass and to report and to log. But if you look at this spreadsheet template, over here is where that data is going to be entered, okay? And it's as simple as clicking on the cell, the box, and then typing in the values that you get. So here are a couple of penny masses that I obtained when I was in the laboratory. I want to mention a few things about this first before we go a little bit further. But if, okay, we asked you to do 20 or more, then you're going to see additional blanks over here or boxes that are going to be listed. Or if I tell you to do 30 or more, again, you're going to see boxes that represent each penny that you have done. So this particular year, we did 10. And to be honest with you, 10 worked out pretty well. And with those 10 measurements, because that did work out pretty good, we're probably going to keep it 10 maybe in the next year or the year after. If we decide to change it later, we can go back to 20, we can go back to 30. But again, we will let you know what to do for that particular year. But as far as the spreadsheet goes, it looks like, folks, we just got really 10 measurements, and that's about it. Okay, so to enter data into Excel, I'm just going to take the mouse and I'm going to click on the box, and this says penny year. So I'm just going to type in 2001, all right, and then 1998, and then 2016, and then 1999, great year, and then 2001. And then I'm going to go back and do 2018, and then 2024. And I'll just kind of keep filling these in as needed until I get all of the measurements completed. All right. So this really depends on your random selection of pennies that you have obtained in the laboratory when you visit us. Next up are the penny masses. And the penny masses, again, you just click on them, key in the number that shows up on your analytical balance, and then hit enter, and then just keep entering them all the way down. You want to make sure that the penny year matches the penny mass, of course. A couple of things about the masses. Right here you see 3 digits after the decimal. There are balances in our laboratory spaces that report only 3 digits after the decimal. If you have one of those, that's okay for this lab. Go ahead and report the 3 digits and call it a day. It's not a big deal. But we also have balances that record 4 digits after the decimal. So that really depends on what you have picked or what has been provided to you in order to make these mass measurements with. So whether you've got 3 or whether you've got 4 decimal places after the balance, it does not matter. You will be perfectly fine. But the thing is that you want all of the values to show up on Excel. So right now, if I key in a 4-digit, so 2.4960, and then I hit enter, notice it kind of chops off that last 0. And it will do that sometimes if zeros are ending decimal places. So if the number ends in 0, it normally will drop it, and then it will shorten that kind of numerical entry for us. And I don't want that to happen. If my balance has shown me 4 digits, I want to include the 4 digits. So there is a quick way that we like to do this. The only thing I'm going to do is just highlight. So I'm going to take my mouse and click on the first cell, and I'm going to drag down. So I'm going to highlight the entire column because all of those probably should have 4 digits that are there. And then up in the very top on the home toolbar, so you're going to see that under the section, kind of in the middle, it says number. And then up at the very top, you see a dollar bill, a percentage, and a comma. And then you see these zeros with an arrow that points left, and you see some zeros with an arrow that points right. So I'm going to click the one that goes left and look at what it does to my numbers. Okay. Every time I click it, it will increase the decimal points by 1 space. So that way, these extra digits, if they are going to be dropped off, it is forcing them to be shown. Now, this is a measurement that I have made. It's not a calculation. So it's not like I'm rounding digits. It's not like I'm rounding numbers, right? This is legit the value that I have obtained in the laboratory. So that value is 4 digits, let's say for me, and I'm going to key in 4 digits and I'm going to show 4 digits. So that way Excel does not accidentally drop off one of these values for us. So when I do that, all of these we now are ensuring are going to be showcasing 4 decimal places after the number, and that's exactly what we want. All right. As far as the personal spreadsheet goes, once I have the year in place, once I have the penny mass in place, the only thing that I have to do now is calculate an average and calculate a standard deviation. Very simple, very easy. I'm going to get you to get Excel to do this work for you, though. Do not key this into a calculator and manually type in a calculation. That is not what we want you to do. We want Excel to do it for you. So under the average, I'm going to start this off with equal. Equal is for Excel to do calculations for you every single time. When you start off with equal, Excel is going to go, oh gosh, it's math class. I need to pay attention. What do they want me to do? All right, so when we do this, we're going to start equal, and I'm going to type in the word average, A-V-E-R. Notice it actually populates it already. I'm going to finish it on out because I like to complete the work. So I'm going to hit equal, average, and then I'm going to open a parentheses up. When I do this, notice it now says number 1, number 2, number 3, ... All right, well, it wants me to highlight the data that I want Excel to calculate the average of. So what I'll do is I'll take my mouse and I'll go over here to the column and I'll click on the very first block, and then I'm going to drag down all the way. It highlights the entire column. I highlight all of the data points that I have made an entry with, and then in doing that, I'm going to close the parentheses out. Right? We need a full set, a first one and a last one, and then I'm going to hit enter. So now what it has done, it has automatically calculated the average of that set of numbers for me. So it has taken 2.496 plus 2.503 plus 2.5170, blah, 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 and it's added them all up. And then it's divided it by the number of data points that was there. And in this case, it looks like around 10. So that's how it calculated an average for me in Excel. That's how we would calculate average by hand. But get Excel to do the work. You saw how quick and easy that was. That's why we have the power of Excel. That's why we use it. So take it, use it to your advantage. I mean, don't snub your nose to the technology piece, right? Use it. Just don't tell a math teacher. Next up, that 2.505, notice that's 3 digits. All my measurements were 4 digits after the decimal, not 3. So I want to make sure that that is actually showcasing 4 digits. So I'm going to go up here to the top, and there under the number section, under the home tab, I see a number, and that's where my 0.00 to the left is at. So I'm going to press it 1 time, and that allows me to showcase 4 digits after the decimal. If you used a balance that was 3 digits, your average will be in 3 digits. If you used 1 and 4, your average will be with 4. If you used a top loader balance that only goes to 1 or 2 decimal places, then your averages will be only 1 or 2 decimal places. So you make a match. That's kind of the purpose of all of this. Next up is the standard deviation. So no one wants to do this by hand. Are you kidding me? You want me to do this with possibly 30 pennies? Next, I'm going to take a 0. Okay, well, we've not asked you to hand do it. If you did get 30 pennies, we're asking you to let Excel do it for you. So again, come on, folks, let's use Excel to kind of do the work. So in order to get Excel to do standard deviation, I'm going to hit equal because Excel's now going to go, whoa, math class, I need to do a calculation. Okay, what do you want me to do? And I'm going to hit in STDEV, and I'm going to open the parentheses up. There are a number of different standard deviation types of calculations that are in Excel. Each one of them is slightly different than the other one, but for the most part, kind of showcasing standard deviation, getting Excel to do calculations, I am okay with the basics of the basics, and that is STDEV, and then open the parentheses up. If you type in anything else, there is a slight chance that you will get a weird little number that shows up. It'll be super close, but it'll be a strange little rounded off number possibly, and we just don't like that type of scenario when we go through and we just check your calculations. So it's always best to kind of keep it the same across the board. So STDEV every single time works for me. I am okay with that, and that is a proper standard deviation calculation, right? Excel knows what that means. So I'm going to open the parentheses up, and now I'm going to take my mouse and I'm going to go over and I'm going to highlight the column. There we go. Once all of the data gets highlighted, I'm now going to close the parentheses out so that way we get a full set. And now I'm going to hit enter. Ta-da! It just now calculated standard deviation. It is simple and quick as that. So if I had 30 pennies, if I had 100 pennies, it does not matter, folks, because Excel will make very fast work of these type of calculations, which is the power of Excel. And that is why we love these Excel templates and spreadsheets, because it makes very fast work of some of the math. And I think no one's going to argue with that. Here, standard deviation, we like for it to match the number of decimal places again. So my measurements will made with 4 decimals. My average is reported in 4 decimals. So I'm going to click on standard deviation and I'm going to increase it by 1 decimal place. And there we go. So there's 4 decimals with standard deviation. Now, that is a low number. We talked about standard deviations being low numbers are very good things. And that's great, right? I mean, no one's going to argue with this. Does that mean I did a good job? Well, there's actually more to the story than that. Standard deviation is one step in the right direction, but there are other statistical parameters that we look at when we start doing these types of calculations. But standard deviation is going to have to be calculated for those, and averages are going to have to be calculated for those. So again, baby steps, that's what this is all about. And as long as you do average, as long as you do standard deviation, folks, you are done with the spreadsheet. That is it. So manually key in to Excel, get familiar with it, get Excel to do an average, get Excel to do a standard deviation, and folks, you are now finished with this particular lab. So if I go back to the lab document, as I scroll through, it's going to tell me, oh, okay, well, you're going to do this and you're going to do that and you're going to key it in. And then there is a part 3 and it says classroom data. So I'm going to show you that in just a second. But notice that this is really it. There's no questions to really answer with these types of labs, or this particular one at least. It is just go do some measurements, report them, go to Excel, key them in, save them, print them off or upload them, whatever we decide to do. Okay. All right. So now that you have that finished, and hopefully you'll do that in class before you leave on that particular day, there is another link, and this link says shared classroom penny spreadsheet. This is something different, and this is kind of the part B to the entire lab experiment. So what we've done is that for part A, under the first link, you have a personal spreadsheet that represents your data only, that you have done an average and a standard deviation on your data only. That is it, nothing more. So for part B, it's going to say, hey, there's going to be a link, and that link is going to be a penny spreadsheet. And with that particular link, you want to click on it, and you want to re-enter those numbers into this classroom master spreadsheet now. So I'm going to click this link, and I'm going to open up what this thing's going to look like, and I'm going to briefly talk about it just for a few minutes. All right, so when I click this link, this is going to open up a spreadsheet in on your internet browser, whatever you decided to do. And I want you to understand that this spreadsheet is a live spreadsheet. What that means is that any changes that you are making in the spreadsheet is going to be active. People can see it getting changed in real time. And if you delete any data, anyone else's values that they have keyed in, you are deleting their data from a live spreadsheet. So simply, you're to enter your data only into this classroom master spreadsheet. That is it. It automatically saves all of your changes. So here's the view of the shared master spreadsheet. Notice there's already data in here. There probably will be, unless you're the first that will key in data into the spreadsheet. But this is someone other's entries, and I don't want to mess with those. So what will happen is that I will just simply scroll through the spreadsheet, try to find the year. Keep in mind that the spreadsheet does scroll and keep going right-handed. So you'll find your column and you're like, oh, I've got a 1993 penny. So I'm going to click on that cell under the 1993 column and I'm going to key in 2.4601. Who do we appreciate? Me! All right, so I'm going to key that number in. I hit enter and then I move on to the next year that I've got, maybe 1987. I key in a number there. And then I go to the next year and I make sure I don't overwrite someone else's values, and I click in that box and I key in my data or my mass measurement, and then I just keep entering them in one by one by one by one. So when I key in my 10 or 20 or 30 pennies, whatever I decide to have, that is it. I don't want you to do any more. All right, so if I scroll down, it's going to give me 2 rows, and the rows will say average and standard deviation, and it looks like it's going to break them down per year. I do not want you to do any calculations at all on the live spreadsheet. What will happen is that once everyone enters their data into the live spreadsheet, we will save a hard copy of this, all right, and we will send you this copy to your email. That way you can do your own average and standard deviation calculations. And when you do your own calculations here, then you can submit this spreadsheet as well, and we will review it and make sure that it looks okay. If you try to do your average and standard deviations in the live display, everyone else is going to see it. We will delete those values. So make sure that you wait until we download a copy of this one, and we will send you the unlive, if that's a word, version of the spreadsheet for you to use. Okay, so simply click the link in Canvas. When you click that link in Canvas, this will open up, and the only thing that we're asking you to do on the live spreadsheet is data entry, nothing more. All right, save the calculations until a little bit later. All right, so that's going to be our very first lab. Again, it really introduces you to the balance if you've never used one before, which is great. We'll probably showcase our balance printers as well, so that way you've got a hard copy of all of the measurements that you have made to make sure you didn't lie about any data. That's a thing. That's part of quality control. And you'll take that data, complete a personal spreadsheet, and then you'll take the data and enter it into a shared classroom spreadsheet as well. So with that said, that's kind of all that I want to talk about this for now. There is a chance that these data points will come back up later. There's a chance that we'll do something else with the data that we are generating with these little simple penny masses. But I'm going to keep that a secret until we get to that point. So have fun in the lab. It might be your first day in the lab with us, and if so, great, we welcome you. We don't want you to be nervous. We don't want you to get weirded out. If you're a returning person to our lab, this is going to be super quick and super fast for you. So you know how to use our balances. You probably know how to use our balance printers. Go to town with it, folks. Generate that data, complete those 2 spreadsheets, and you're out the door. And then we'll see you next time. But if you need some help and you don't know what you're doing, please feel free to ask. That's why we're here. If I don't have any questions to ask and I don't need to teach anybody anything, then we just don't need a job, do we?